Hello everyone, mic test. Can you all hear me? Hello everyone. Delvin, Dallas, Tianam Kwan, Jamie, Jennifer. Yep. Okay. Hello Javen. Okay, like there's something wrong with my phone today, so I'm gonna monitor this through my other monitor. Okay. Yep. Right. Okay. So welcome to tonight's Facebook Live teaching, brought to you by Maths Heuristics. Alright, so if you haven't already, you can download the notes at mathsheuristics.com/blog. Okay, so today we'll be covering on area and parameter again, with certain advanced techniques that is not commonly seen in exams. Okay, so a bit about myself. I'm Kevin Huang. I've been doing online teaching since 2016 actually, but I only started it seriously around 2017, accumulating to Facebook Live coaching since August 2017, and I started teaching Zoom in 2018 to full-time online classes from P3 to P6 math. Okay, so a bit about our company. We've been established back in 2008, and this is my boss over here. Formerly he had long hair. Okay. So this was way back in 2011, where the Business Times interviewed him, and he was saying that his 5-year aim is to see every student in Singapore use the heuristics method, and it doesn't matter where they learn it from. And true enough, lots of people are teaching heuristics these days to primary students. So in a way, his vision has been fulfilled. And a bit about the Mastering Heuristics series. This is a set of books written by my boss, and today we will be emphasizing on spatial visualization. Okay, and a few of the techniques described will come from this book over here. So if you want to find out more, you can click here to find out more first about the Mastering Heuristics series. Hello, Wykit. Okay, yeah. Right. So it's a bit different for me this time, because I'm monitoring this on my monitor rather than my phone. Okay, but anyway, so right. Without further ado, let's jump right in. There's like 5 questions I need to cover within the next 55 minutes or so. Do you use StreamYard for live lessons? Not yet. I haven't figured out how to do it yet. Okay, the figure below is made up of 6 similar rectangles and 1 square. The perimeter of the figure is 84 cm. Find the area of the square. Okay, here's a few things that I observed some of you would do. Some of you who rely heavily on algebra would do this. Okay, you would eventually come to this conclusion where you say that this is 1.5 units, this is 1.5 units, and then you find out the area. It will be 2.25, and here is where a lot of the common mistakes are made, because you're not too sure on how units multiplied by units work. You leave it as this, and then you end up with a mistake over here, because over here you're missing out something. So if you're not too sure how to deal with this, how to deal with it this way, Here's an alternative that I can show you. And this idea also is also applied to this PSLE 2017 paper over here. Okay, this was back in 2017. I think if you buy the booklet this year, you would be able to see it. The idea here is that you want to cut this up into squares first. And depending on how you tackle this question, you can also cut them into smaller squares like this. Okay, this is not the only way to do it. So what I want to do is, or what I want to emphasize here is on the idea of drawing of lines. Okay, hello to Emily, Eunice, Ashlyn. Hello to RNH. Okay, wait. What's wrong with my stream? Okay, so anyway, the idea here is when you look at this picture, what can you do? Or what can we say? If we are to isolate this region here. Okay, if we are to zoom in closer to this portion here, we can see that three breaths have the same length, or rather is the same as two lengths. So the idea here you want to do is you want to make them the same. Alright? So to deal with this, okay, hopefully you got a ruler here. You want to cut it up like this. Okay, maybe I should use dotted lines for this. Okay, you want to cut them up like this. And you would see that breadth-wise, you can cut every rectangle into 6 smaller squares. True? So every rectangle can be cut up like this. Hello, Kayla. Alright, so once you got this already, we can cut this further up like so. And you see that if we are to cut them up like this, we would end up with, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. We would end up with 28 small squares length. Okay, if 28 small squares length represents the parameter of this 24, then we can say that one of those small squares length will be 84 divided by 28 to give you 3. Correct? So are you all following me so far? Okay, you all cut it up first. And by doing it this way, you see that this large square over here, which is what you intend to find, whose area you intend to find, the length will be 3 times 3, which is 9. So by doing this, you bypass the need to use 2.25 units squared. I mean, I have some students who can do it this way. And for them, I say if you're comfortable with it, just go with that. But as long as you're aware of it, it's fine. Then the area of this large square then will just be 9 times 9 to give you 81. So the answer here will be 81 cm squared. Okay, well done, Delvin, Emily, Mala, Ryan, Miriel, Keshav, Jaden. Yeah, Keshav, as long as you know what you're doing, that's fine. Okay, question 1 is not 196. Okay. Yeah, Jamie. What if the drawing is not to scale? Okay, what if the drawing here is not to scale? You want to try to redraw it to scale then. Then the second way you can do it is you label these as units, but you try not to. But okay, if you're labeling it as units, right, the other way this can be done, 1 unit, 1 unit, 1 unit, then these would be 1.5 units, 1.5 units. So the length here of the square will be 1.5 units. If you're doing it by that way, you want to evaluate what your 1.5 units is first. Evaluate this first, then you do the 9 times 9. Because, okay, this is the problem I was talking about. If you have 1.5 units, right, if you don't know what's going on, this is what you may probably end up with. You say that this is the area of the square is 2.25 units, but you're missing out the square here. That's why I don't want to go by this approach. If you can, you evaluate this first, because there are a few rules that you have to be made aware of before you can do these types of operations confidently. Okay, Ashlyn, yes, that's true. This is the confusion alert I need to point out. Right? So today, as you notice, there's no polls, because the last time I did the polls, right, this was what you all did. This was what you all selected. So no polls for you today. I'm not gonna answer no matter what you do. With this angry penguin face over here. Okay? So yeah, no polls for today. Angry face gang is back. Now there will be bound to have people like this one, jiapa sibei heng one. No polls for today. Okay, so anyway, let's move on to number 2. You all done ready? You all done ready? Then I'll just move on to number 2 first. Hang on, let me. Angry face gang is back. Why like that? Okay, so anyway, once we've got this, I want the music. Later. Overwhelmed. Okay, next one, number 2. So the figure below shows a rectangle ABCD measuring 10 cm by 8 cm and a triangle CEF. Okay, so this one is your 10 cm here. This one is 8 cm here. The length of DF is 20% the length of DC. So even for spatial visualization questions, you want to change these percentages into fractions first and then allocate your units. This will make it easier for you. Okay, this will make it easier for you to interpret the problem. So let's just try to simplify this first. Now if this whole length is 10 cm, this length here is 1 out of a total of 5, which means that this is 4. Then we can say that DF has to be of length 2 cm. Okay, simplify the problem first. You will hear me say this over and over and over again. Simplify the problem first. Hopefully, it gets drilled into your subconscious that you know what to do during the exams. Okay, simplify the problem first. So now we are to find the difference in the two shaded areas. Now my question for you here is this. Okay, let's say we call this area X, let's say we call this area Y, let's say we call this area Z. Is it possible for you to find out the area of X and Z individually? Like, what happened to this? Okay, is it possible for you to find out the area of X, Y, or Z individually? Hey Melvin, don't do this here. Excuse me. At least not for this problem. Okay. Okay, not for this problem. Alright, it's not possible for this problem. Because there is not enough info. Right. So to deal with this instead, because we are only asked to find the difference in the two shaded areas, what we can do instead is to group them up and use whatever known formula we have. So if we are to group up X and Y together, we would have the area of a rectangle, of the rectangle ABCD. Okay. Right? So the rectangle itself its area can be represented by Y and X. So this area would just be 10 times 8 to give you 80. Length times breadth to give you an area of 80 cm squared. Okay, RNH. What you're doing here is not quite correct. Okay, so the next one over here is for the triangle. FCE, its area is comprised of this guy over here. Right or not? So this area is Y, is comprised of sections Y and Z. And then the next question is, you want to find out its area, what is its height, or what is its perpendicular height. So we see that this point E is level with point B, and since this is a rectangle, this angle, this particular angle here, will be a right angle. And if that is the case, the perpendicular height will simply be 8. So the area then will be half times 8 times 8 to give you 32. Right? So once you know this, the next thing you can observe is that to compare the difference between X and Z, we just need to focus on this portion. Use your eyes. And this portion here will be, because both of them are comprised of the same number at the beginning, that will cancel out each other. The difference over here would simply be 80 minus 32 to give you 48. So the answer here then will be 48 cm squared. Okay? You all got that? You understand so far? Okay, okay, I'll give you all a bit of time. Continue playing this first. Okay, Connie, Li Ling, Mirel, Keshaf, Kayla, hello, Diane and Diana. No, that's not what you said. Okay, to address this question, right? Okay, you see RNH comment here, x plus y minus y plus z. You know what you're missing? You're missing a bracket here. Okay, because if you do this, if I go according to what you wrote, this would be x. The y's will cancel each other. You have x plus z, which is totally off from what you want to find. Okay, just to address this issue. Okay, so it's, I think I would say that you got the correct idea, but the execution was off because you're not too sure about how the negative sign affects grouped up terms. Okay, so next up, over here, number 3. Okay, the diagram below shows 2 quadrants and a square with length, 10 cm. Find the difference in area between the 2 shaded parts. So again, this one is on the difference in area. Okay, so the key idea here is that when you're dealing with the difference in area, you don't necessarily need to obtain the individual values first. Okay, Lena, later I answer you on that, okay? Okay, yeah, Wykit, you're correct. So over here, take pi to be 3.14. So again, same idea. You want to break this down into various sections. Let's call this A. This section will be B. And because of how these quadrants are arranged, this section will also be the same area, and this will be C. I think that you slice it in half. Well, good attempt, but not really. No, Jaden, what's your problem? Jaden, why? You're the one that spammed the angry face. Emily, what's your issue? So over here, once you got this ready, let's find out whatever that can be found. You have the areas of A plus B over here, which is basically the quadrant. Right? So the quadrant's area can be found rather straightforwardly. It's just 1/4 times pi times radius. Its radius will be 10 because this is the center, this is the radius. So this would give you 78.5 cm squared. Okay, Victor, you're correct. Okay, so this whole area here is 78.5 cm squared. Okay, then if you observe between B and C, B is a common area between them. Then we can use this. We can say that because B is over here, B is shared between them, we also need to find out B and C and get rid of this B over here in order for you to obtain the difference between B and C. So this, what shape you all call this, boomerang or what? This boomerang area, or whatever you want to call it, will be the squares area minus the quadrants area. (100 minus 38.5 will give you 21.5. And using the same idea as just now, as discussed earlier, the difference between A and C now would just be 78.5 minus 21.5. So that will give you 57. So the answer here is going to be 57 cm squared. Yeah, Emily, wait, Victor is correct. Keshav is correct. Delvin correct. Kayla correct. Leaf, if I'm not wrong, is this one, right? Okay, boomerang, teacher calls it that. Banana, cannot too sure what you all call it. That definitely doesn't look like a banana to me. It's called the curvy. Connie, you're correct. Keshav, correct. Wait, just hey, don't spam. You want to spam, you spam the like button, but you don't spam this one here. Skateboard ramp. Yeah, so there's a lot of different names. Yeah, Manikandan, you're welcome. Yeah, Emily, you're correct. Trying to look at your name, the Facebook username, and I'm trying to remember which student is it from. Ashlyn, correct. GL Huang, correct. Sorry, but why do you take 78.5 minus 21.5? So the reason here is that you cannot find, okay, the summary here is that there is not enough info in this queue, or rather, there is not enough info to find the individual areas of A or C using the formula at the primary level. So because of this, we have to find B and A first, B and C together, and get rid of the B's from here, so as to obtain this this difference, because you can think of this as a difference unchanged problem. Alright? Can name the shape after you? No. Yeah, so there is no way for you to do this at the primary level. Maybe at more advanced stages you got some other tools that you can find out. Alright, but not at the primary level. So anyway, once you got this ready, this will be 57. It is exactly the difference between A and C. The objective here. Right, the B gets removed. How come you have not posted the T-sharp? I posted already. Last week I already whacked the... I already speed run and posted up quite a lot for tomorrow. Okay, Alina, to answer your question on this... Wait up. Okay, Lina, I cannot find it. I screw up all the way already, but I cannot find it. Later you ask me after the thing can. Yeah, I did. I posted up already. P6 week 33. Okay, later I go and check again. Okay, the two identical right-angled triangles overlap each other as shown below. Find the area of the shaded part. Okay, how do we deal with this? How do you know AD is 8 cm and DC is 10 cm? Okay, yeah, that's the thing. Okay, so before I go into this, I answer Lina's question first. Usually when they specify the dimensions like this, the first one is the length. The second one is the breadth. Usually. Okay. Alright, so anyway, number 4. Maybe you want to attempt this for yourself first. The idea is similar. It's just that it's applied a bit differently. Keyword here, two identical right-angled triangles overlap each other as shown below. So you want to call this section A, this section B. Aiyo, why I keep on? And this section C. Okay, are you able to find it out? So you want to find the area of the shaded part. What can be done from here? Okay, that is very good. The area of C is the same as the area of A. Okay, but there's a little bit of a twist to this. Okay, so the area of A is the same as the area of C. Then how do we visualize this? Now, both triangles have the same area because they are identical. Okay, so here's a way to visualize it. If we are to draw out the second triangle over here, whose area is B plus C, it must have the same length as the model above it, because they are identical, hence they have the same area. So because there is not enough info, to find A directly, you want to find C instead. Okay. So now for this trapezium thing, if you don't know how to use the area of a trapezium, it's okay, because I'm not planning to use the area of trapezium to find out the area of C. So here's what I'm going to do. This is the part most of you would stumble. Like, how are you supposed to find out the area of C? Okay, Kayla, which part are you confused about? Yeah, you want to cut them up first. So let's just think of it this way. Okay, let's just say that this trapezium here. Okay, let me get rid of this guy first. Okay, let me get rid of the page number. This one here. 17 cm, 25 cm, 3 cm, right? What I can do from here is I can cut this up like this. And I will obtain a rectangle whose length is 17 cm and breadth is 3 cm. So this one is difference in area plus rearrangement. Then for these two triangles, okay, these two triangles, you don't know what these individual lengths are. But what you can say is, if you put them together like this, okay, let me get rid of this also first. You can say that this length will add up to give you 8 cm. And this height here will be 3 cm. Okay, wait first. If you all got the answer, good. Okay. (17 cm) is this guy over here, this length over here. Okay. So once you know all this already, right, the area of C can be found rather easily. That would just be 17 times 3, 51 cm squared, plus the area of the triangle, which will be half times 8 times 3. So that will give you 12 cm squared over here, for a total of 63 cm squared. Okay, so the answer here will be 63 cm squared. Can't you say that it's 4 cm for base of each triangle? So here I got one comment that I think I need to address, because I think it's a very common misconception. So here they say that, can you not assume that it's 4 cm for each of the triangle, like this and this? Okay, the answer is, if you are doing it for demonstration purposes, to give you a concrete number to feel your way through, yes, but you do not show it in your workings, because if you do, if you say explicitly that this is 4 cm and this is 4 cm, you will get marked down, because you are assuming something that may not necessarily be true. Okay, so the idea here is, because you haven't learned how to deal with a trapezium yet, this is what we can do. Of course, if you know the area, if you know the formula for it, you can also do it by that way. Yeah, Maggie, you can definitely do it by that way. That's also fine, if you know how it works. Okay? Okay, so everyone got this? We don't know whether it's identical. No, they have to be identical. Because the two identical right-angled triangles overlap each other as shown. So we have already proved that the area of A is the same as the area of C. You see that? Okay, when you say you don't understand, which part do you not understand? GL Wang. Yeah, thanks Delvin. Okay, what's the formula for area of trapezium? Do we need to know? The answer is no, you don't need to know. At the primary level, no. Oh, okay. Talking about the small ones, yeah, we don't know whether is it identical or different. So, but as a group, this entire length, this length plus this length will definitely be 8 cm. Okay. Why 17 times 3? You want to find out this area of the rectangle first. Then the two of these add up to 12 cm squared. Okay. Okay, let's move on to number 5. Speed run addition. Okay, W XYZ is a rectangle measuring 9 cm by 7 cm. If the total shaded area is 27 cm squared, find the area of triangle VYZ. Okay, thanks Navin. DJ teacher in the house. Yeah, thank you, Chin Yong Chun. Hey, so anyway, okay, no music. But we're explaining no music because if not, it's gonna distract some of you. So I will not play the music. Okay, 9 cm, 7 cm. How many questions are there in total? Just 5. 1 hour clear 5, I think quite okay. In the T-sharp class, you can ask them, I easily clear 10 or even 12. This one is more relaxed. A more relaxed session. Wait, where was I? Okay, thank you for all your wishes. Let me just what you call? Okay, let me see where am I. Okay, the total shaded area here and here is 27 cm squared. So first thing I want to say is, if you have this area here, we call this region A, and we call this region B. Why okay, we call this region A. We call this region B. And we call this region C. Okay. Now, what can you say about these triangles area? Incredible shading, thank you. Yeah, okay, can you all see that A plus B, the region of A plus B, okay, let me call this region P. The area of PZY is the same as the region, the area of triangle ZXY. Are you all able to see this? Okay, Jenny, you're correct. Dallas, you're correct. Maggie, you are correct. May Ao, you're correct. Also, B is repeated between them. Emily, you're correct. Okay. So, once you got this, to help you visualize further why the area of A is the same as the area of C, here's what we can do. Okay, draw this model first. The reason why this is the same is because they have the same base with the same perpendicular height. Alright? Same base. Same perpendicular height. So B and A, B and C. If we draw these two bars, they should have the same length, and it follows that the area of PZY, which we call A, is the same as triangle ZXY, which we call C for convenience. A plus C equals to B? No. But once you got the idea, the total shaded area here is 27 cm squared. It means that the two of these would have an area of 27 cm squared. Which means to say that, okay, Nausea, yes, you're correct. Nausea, you're correct. So you take 27, divide by 2. This will give you 13.5 cm squared. This area here will be 13.5 cm squared. This area here will be 13.5 cm squared. You all see that now? Okay, Maggie, you are correct. So now to find out the area of triangle VYZ, which we call B for convenience, we can find out the area of A plus B first. Okay, the area of A plus B will be half times base 9 times height 7, perpendicular height 7. That will give you 31.5. So when you know this to be the case, we can just take, okay, this whole region here will be 31.5. And since we found out that this is 13.5, the area of B would just be 31.5 minus of 13.5. Which will give you 18. So the answer here is 18 cm squared. Okay. Okay, so you made it to the end. Ayo, if I put it like this, can you all see the music? Okay, Emily, Joan, Yo, Keshav, Naveen, Kayla, you all got it. So this deals with overlapping area. Here's how you can break it down. Alright? Cannot hear the music. How about now? I don't want it to drown out my voice, you see. Okay, like it, you got it. Okay, Mala, you're welcome. Okay, Kenna. So you made it to the end. So the good news is during this holiday, we will be conducting more classes on this. For spatial visualization for P5 and P6. Of course, we also have classes for P4. Now the way we arrange this It's gonna be a bit different because we will conduct the same lesson with the same ideas for P5 and P6 on 2 days, 9 to 10. And for P6, there will be one additional day on the 11th of September where we will be focusing solely on the problems for P6. So if you want to sign up, here's the link in the comment section. So for those of you who attended before, you all got the replay, you all got the ebook, and best of all, you all got me. Alright, this will be conducted by me, this will be conducted by me. Alright, so if you all have any questions, you all can ask me first. No, it's not fail, boys. Okay, better not. Anyway. Yeah, the last thing I want you all to do is to start a new game and suddenly get addicted to it. Hey, welcome Jamin. Welcome Emily. Yeah, welcome Zhenhui. Okay, welcome Corley Ling. Okay, thank you Delvin. Okay, for question 2, how do you know that this is... Okay, I mentioned before, this one by right, usually 10 cm. Okay, if they mention it in this order, this is usually the length, this is usually the breadth. Okay. Okay, those of you who signed up before, no need to sign up again, just watch the replay. The ideas will be very similar. Okay, welcome Dominic. Thank you all for your well wishes. Can you go back to question 1 for a while? Okay, right. Cringe level goes up to infinity. Okay, bye Emily. 4 hours 8 minutes more. Hey, thank you Javen. Can you put the link in the chat? Yeah, I put it in already. Okay, what else is there? Hey, thank you Mala. Hey, thank you Ashley. Okay, welcome Julia. Oh, better delete, better delete. Hide comment. Hide comment. I cannot find it. It's over here inside the pinned comment. Can you play Ice Cream from Blackpink? I don't even know. I don't know all the K-pop songs. Hey, thank you Javen and Zhenhui. Jamie also. Happy journey. Okay, thank you Manikandan. Then it's over here. Do you see the mouse cursor? Yeah. Okay, hide comment, hide comment. No plug. Why everyone all spamming all the songs? Hide, hide, hide. Can I see the last question? Okay, wait, give me a while. I hide all the comment first. Where's the thing? Yeah, this face is priceless. Okay, thank you, Annosia. Where is the pinned comment? You try to open up your chat, you should be able to see it. Okay, wait, I try again. Okay. It's jialat. Okay, wait. I see whether I can PM you or not. Okay, I put it here again. Then I'll try to PM you from here. Okay, anyway, the session is over already. 5 questions, less than 1 hour, less than 50 minutes. I think that's not bad already. You're welcome, Keshaf. Can you all see in the chat? Hey, bye Javen. Hey, you all go and sleep early first. If you don't have any questions for me, just go and rest well first. Okay, still got less than 30 days. Technically, it's less than 30 days, right? Yeah. Can you quickly post the P6 question for tomorrow? Okay, later I go and check on it. Right? Yeah, I'll end the session at 9. Let's enjoy the vibes first. What is next week's lesson on? Geometry, angles. Okay, do like and share. Yeah, welcome Jennifer. Is there lesson next Wednesday? Yes. Yeah, it will not. The holiday class will not clash. Okay, bye bye. So you're still hanging around because of the music or what? See, like still got 51 people like that. Bye bye. Okay, no further questions, then I'll take my leave now. This is Kevin from Heuristics signing off. See you all soon. Bye bye.